Hello, welcome to Tutors. If this is your first time of coming to our channel, please do hit the subscribe button and also hit the notification bell. Now, we're going to be treating the topic set. Now, this is a foundational topic for set, so it doesn't require you to have any prerequisites for any of the maths topic. So, as you can see listed below, it's what we are going to be studying in this topic set. So the first thing we're going to be discussing about is what is set, and secondly we'll be talking about the properties of set. Set has several properties, and the third thing we'll be discussing is the intersection, union, and complements of set. These are also features of a set. So for you to be able to successfully solve a question under set, you need to know this. Then also we'll be discussing about Venn diagrams, how to represent sets on Venn diagrams. We'll be discussing about using the 2 circles and also using 3 circles to represent sets on a Venn diagram. Now, we're going to be solving a whole lot of questions on set. I think we are going to be solving close to 15 to 20 questions on set, including multi-choice questions. So if you stay with me through this video, you are going to get everything. Okay, so let's get on. Okay, the first thing says, what is a set? A set is a collection of items. A collection of items. It could be the shoes in your closet. It could be a collection of cars in a particular compound. So whatever, as far as you can relate to a particular set of items, you can call them a set. And these items are described as the elements of the set. Okay, so all the elements, if you say the shoes in your closet are a set, then all the individual shoes are the elements of a particular set. Now, for instance, we have earths to be equal to odd numbers, 0 and 10, odd numbers between 0 and 10. Now, you understand that odd numbers between 0 and 10 includes 1, 3, 5, 7, and 9. So you can say 1, it's an element of this particular set, earths. 3 is an element of this set, earth, and so on. So all the elements listed are this. All the items are the elements of the set. Okay, so now properties of a set. Now a set has several properties. One of them we're going to be discussing about is the equal set. Now 2 sets are said to be equal if they have exactly the same elements. Now I'm going to give you an instance. For instance, if we say A, which is a set, has the numbers 2, 4, 8, and we say B has the numbers 8, 4, 2. Now, when you compare both A and B, yes, you can understand that the same set of elements are repeating itself, except for the fact that they were not arranged in ascending order. Yes, in A, it was arranged in ascending order. In B, it's in descending order. But the elements that is in A can be found in B. So when we have this kind of condition, we say A is equal to B. So in this kind of condition, you say the sets are equal. The next one we'll be talking about is the empty set. Now, a set is said to be empty. Just like when you solve a maths question and you get 0, in set, we don't connote our answers as 0. So we connote it as an empty set. And a way we represent an empty set is by using the symbol that. Or you can also use a bracket, a parenthesis that has nothing inside. So when you do this, you say this is what? An empty set. So there are several questions that we're going to be solving that would show us how we're going to get an empty set. So when you don't have anything in the list of elements, like the items are empty, then you say you have an empty set. Okay? So some of the properties we're going to be talking about includes the finite and the infinite set. Okay, so the finite set, in a finite set, a set is said to be finite if all the elements can be listed. Yes, now there are some list of sets where you might want to list all the elements and state them down in your book. For instance, let's say A contains even numbers. If we say A is even numbers between even numbers from 0 to 10. So you know that A is going to be 2, 4, 6, 8, and 10. So these are the even numbers that can be found. So you can see that this is a finite set. We can list all the elements. For instance, if we say A could be all the prime numbers that are less than 100. Yes, we can count all the prime numbers that are less than 100. Now, if we're talking about infinite set, a set is said to be infinite if the elements are unending or unlimited. For instance, someone can ask you, can say A is equal to all even numbers. Now, I can tell you, if you want to list all the even numbers, you're going to get tired, and you can't even do it because it's unending, it's unlimited, it's infinite. So for the fact that we can't list this, so we are going to say this is an infinite set. So to list this, we're going to write 2, 4, 8, 10, 12, and so on. So this is what we call an infinite set. So it is unending. Okay, so the next thing we're going to be talking about is a subset of a set. Now, for instance, if you have U, let's say U is a universal set, and U contains 1, 2, 3, 4, and 5. We have our A to contain the even numbers, which are 2 and 4, and we have our B to contain the odd numbers, which are 1, 3, and 5. Then we can actually say A and B are subsets of U. So U is the parent set, A and B are seen as the child set. So we connote the term subset as A is a subset of U. Then B is a subset of U. So that can be found in U. So that is why we say it's a subset. So U is a parent set, A and B are the child set. Okay, the next one we'll be talking about are disjoint sets. Two sets are called disjoint if they have no element in common. So when there is nothing in common between the two sets, you say they are what? Disjoint set, or they are not equal. Okay, for instance, we have the set S, which is 2, 4, 6, and 8, and we have T to be 1, 3, 5, and 7. As you can see, there is nothing common between both of them, so you can say S and T are disjoints. So they are disjoints. Okay, so that'll take us into intersection, union, and complement of a set. Now, in solving several questions for set, you're going to encounter the word intersection several times. You're going to encounter the word union and complement of a set. Now, the first thing you need to know, let's go ahead and discuss the term intersection. In mathematics, the intersection of two sets, A and B, denoted by A and B, it's the set containing all elements of A that also belong to B, or equivalent, all elements of B that also belong to A. Now, to summarize this whole statement, it means things that are common to both A and B. What are the elements you can find in A? Can you also find them in B? If you see them, then both those particular elements intersect each other. For instance, if you have A to be 2, 4, 6, and 8, and you have B to be 2, 3, 5, and 7. A intersection B is going to be what can be found in A and can also be found in B. Now, if you check, you will notice that it is just the 2. So because it's just 2, so we're gonna connote our A intersection B as 2. The reason it's because it is just dates that can be found. Okay, so A intersection B here, it's 2. Now, union. The best way to describe the word union for you is to use the word marriage. Yes, you understand the word marriage. When two people are joined together, they are like, instead of having them individually, they are now joined together. So when you unite a set, you add up the set. It's like addition. All the elements are added up together. So when you say A union B, you add up the elements of A to the elements of B. So for instance, we still use the same example. If we were to say A union B, okay, from our example, now A union B is going to be 2 can be found, 3 can be found. So 3 is coming from B, 4 it's coming from A, 5 is coming from B, 6 is coming from A, 7 and 8. So considering that the fact that A is 2, 4, 6, 8 and B is 2, 3, 5, 7. So A union B is going to be 2, 3, 4, 5, 6, 7 and 8. And notice the 2 we have, we cannot repeat the 2 twice because 2 is just an element. So that is exactly the meaning of A union B. Now the last one we're going to be talking about here, it's the complement of a set. Now the complement in set theory, the complement of a set refers to elements not in A but are found in the universal set. Now like I said, the universal set is just like the parent set. No, so let's assume A includes 0, 1, 2, 3, 4 and 5. And let's say B, it's now 2 and 4. So we want to look for B complement. As you can see, B is a subset of A because all the elements that are in B can be found in A. So A is the parent set, B is the child set. So what are the complements of B? Now remember we said complement is the element not in that set but can be found in the universal set or the parent set. Now, what elements cannot be found in B here? Now, we're going to say there 0, 1, 3, and 5. So B complement is actually 0, 1, 3, and 5. Okay? So I would want us to solve a little example so we can get to understand the word intersection, union, and complement. Now, we have our question. The universal set is 1, 2, 3, 4, 5, A is 2, 4, and B is 2, 3, 5. So the first question says we should find A intersection B. Now, to solve A intersection B, remember our A is 2 and 4. Our B is 2, 3, and 5. Okay? So A intersection B, remember? Intersection means what are the things that are common to both sets. So now from here, I can see the only item common to both sets is 2. So 2 can be found in A, 2 can be found in B. 4 can be found in A, but 4 is not in B. 3 is in B, 3 is not in A. 5 is in B, 5 is not in A. So our final answer is 2. Now, question 2 says A union B. Okay, now remember our union. We said when we look for A union B, we combine. It's like joining. It's like adding up the set. So it's going to be 2, 3, 4, and 5. Okay? Always learn to add them in ascending order so that you don't get yourself confused. Now the third question says, what is A complement? Remember A complement? We said A complement are those things that are not in A but can be found in the universal set. So for A complement, we're going to have 1, 2 is in A, so we're not going to write 2. 3, 4 is in A, so we're not going to write 4. So we'll have 1, 3, and 5. Okay, so then question 4, that's B complement. It's not going to be items that we can not find in B but can be found in the universal set, and that is going to be 1. There is 2, so we're not writing 2. There is 3, so it's going to be 1 and 4. Okay, we'll have a question that we will be solving on set. Okay, so this question says if D is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with subsets A, B, and C, where A is 4, 6, 8, B is 6, 7, 8, 9, and C is 1, 2, 3, 4. Find the following. Okay, now to solve this question, the first thing we're going to do is I want to represent my A. It's 4, 6, 8. My B, it's 6, 7, 8, and 9. While my C, it's 1, 2, 3, 4. Okay, so the first question says A intersection B. Now, if you remember what we talked about intersection, we said things that are common to both both elements. Okay, so A and B, what is common to both? Now 4 is here, we can't find 4 here, but 6 and 8, it's common. So A intersection B is going to be 6, 8. Okay, so we can find 6 here, we can find 8 here. Now question 2 says B intersection C. So let's look at our B and our C. What's common in both of them now? We can find 6, 7, 8, 9 here. 1, 2, 3, 4. Now you can see both of them are what? These joint sets. They are not equal. So the answer to this is an empty set. Okay? So this is an empty set because, it's an empty set because nothing can be found. Nothing can be found. So remember what I told you about an empty set? You can either write it like this or you write it like this. So that's an empty set. Okay, so question 3, it says A union B. A U B. Okay, so to get our A union B, remember what I told you? You're going to combine A and B without repeating the elements. So let's look at our A. The lowest number we have on our A is 4, 6. Then we're going to have 6 can come since 6 is common to both sides. 7 is next. Okay, then 8 is next, and 9. So this is our A union B. Now 4 says B union C. So same thing applies. So we're going to combine B and C, and that's going to be 1, 2, 3, 4, and we'll have 6, 7, 8, and 9. Okay, then the last question. Now the last question says we should find A union B union C prime. Okay, so the first thing we need to do is find our A union B. So once we get our A union B, then we can find the complement. So you either call it A union B union C prime, or you call it A union B union C complement. So what's our A union B union C? Now our A union B union C is going to be 1, 2, 3, 4. I don't think we have we don't have 1, 2, 3, 4. I think we'll have 6 next. We'll have 7 next. We'll have 8, and we'll have 9. Now, if you remember what we talked about the complement, we said complement can be found. Like complement are those things that are not in the set but can be found in the universal set. So what are those things that are not in A union B union C that can be found in the universal set? Remember our universal set is called D here. So let's look at the numbers. D says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 1, 2, 3, 4. I can't see 5, 6, 7, 8, 9. And I can't also see 10. So the two elements that are not here are 5 and 10. Okay, so that is the solution to this question. So we will be solving several questions if you stay to the end of this series. Okay, so welcome back. Now we will be treating Venn diagram. Now, if you are just joining us, we started a foundational topic on set, and in the previous video we talked about what a set is, the features of a set, properties of a set, and we also talked about the intersection, union, and complements of a set, and we solved several questions. So we were able to nail that. So now we will be talking about the Venn diagram. Now, a Venn diagram is a way to represent sets. So now we are discussing the Venn diagram that has 2 circles. So we are going to be representing all these variables on the diagram. So the first one says A intersection B. Now, remember what we talked about intersection? We said intersection has to do with things common to both A and B. So if this is my A and this is my B, to get my A intersection B, I'm going to shade this region because this region is both common to A and B. So this is my A intersection B region. Okay, so the second one says A union B. Now, when we were talking about the union property, we said you have to combine both items. So now, to get our A union B, we are going to shade things that are common to only things that are common to only A and B. So I'm going to shade everything that is inside A and B. So this is like a combination of both elements in A and elements found in B. Okay, so I think that's for that. So the third one says A intersection B complement. Remember what we talked about complement? We said complements are those things that are not in that particular set but can be found in the universal set. Now it's asking us for A intersection B complement. Now remember our A intersection B, these are the things that can be found in the A intersection B. Now for A intersection B complement, it's going to be those things that are not in A intersection B complement but can be found in the universal set. So you can see I'm going to shade everything that is not in A intersection B. So we to avoid here. And remember also that all the things that can be found in the universal set are inclusive. So I'm going to shade my background. So everything apart from A intersection B, because it's asking me for A intersection B complement. Okay, need to be fast. Okay, so now notice I didn't shade anything in A intersection B. So this is A intersection B complement. Okay, so the next one says A complement intersection B complement. Now remember, we said A complement are those things that are not found in A but can be found in the universal set. B complement are those things that are not found in B but can be found in the universal set. So when you combine both of them, you will now see that it's going to be everything that is outside A and B. So I'm going to shade all the regions outside A and B. So I don't have to shade anything inside because it's already said the complement of A prime and B prime. Okay, so the next one says A union B complement. Now, if you remember our A union B, so let's take a look at our A union B. So this is our A union B. Now the complement of it is actually everything that is outside A union B. Okay, so I'm going to shade everything that is outside, and that will describe the A union B. Now, let me show you something. Notice dates and dates are the same. So it means when you have A prime, A complement intersection B complement is equivalent to A union B or complement. So these two properties are the same. Okay, so the next question says A complement union B. Remember A complement. Now, A complement are those things that are not found in A, and we will exclude all the things in A and include the things in B. Okay, so this is going to be not in A. So I'm going to shade everything I have in B and outside. So because it says A complement, which means not in A. So I'm going to shade everything I have here. Shade everything except anything that is found in A. Okay, so that is for two set Venn diagrams. So several questions could come out. So, but once you understand once you understand your intersection concept, your union, and your complement, then you should be able to tackle any Venn diagram question. Now, this will take us to the 3-degree Venn diagram for 3 circuits. Now, the first one says A union B union C. Yes, I know you understand that now. So we are going to shade everything inside the whole circle. So except outside, because it's asking us for A union B union C. Now this one says A intersection B. So it says things common to only A and B. So I'm going to shade A and B. So every part that has that is common to A and B will be shaded. Now this is B intersection C. So I'm going to shade all these plates. So only common to B and C. And A intersection C, only common to A and C. Okay, so the next one says A intersection B intersection C. So in this case, we're going to shade where the three circles meet, and that is the thing that is common to the three circles. That's A intersection B intersection C. Okay, now this last one says A union B intersection C. Okay, now it says shade everything you have in A union B, then intersect it with C. So it's going to be A union B. So I'm going to shade all my A, so all these parts, but any part that has only to do with C, it's not going to be included. So this part is not included because it's A combined with B intersection C, where it intersects. And this is the point where it intersects with C. Okay, so the question says, I'm giving you it's 1, 2, 3, 4, 5, 6, 7, 8, 9. X is equal to 1, 2, 6, and 7. And Y is 1, 3, 4, 5, and 8. Draw a Venn diagram to illustrate the question. Now, to draw a Venn diagram, we need to get some properties of this set. So the first thing we're going to do is our X is 1, 2, 6, and 7. And our Y, it's 1, 3. Okay, always put them in parentheses. Our Y is 1, 3, 4, 5, and 8. Okay, so now I'm going to get our X intersection Y. So our X intersection Y, 1 is common to both. I don't think there's any other number. So X intersection Y, it's 1. So at this point, I can draw my rectangle. Okay. So then I can draw my circle. This is my X variable. This is my Y. So this is my Y. This is my X. Now, remember our X intersection Y, it's going to be 1. Okay. Now, what other variables do we have in X? We have 2, 6, and 7. So 2, 6, and 7 are going to be in X. Then we have in Y, we have 3, 4, 5, and 8. Now, let's compare this with the universal set. We have 1, 2, 3, 4, 5, 6, 7, and 8. But 9 is missing. It means 9 is not in X, 9 is not in Y, but 9 is in the universal set. So remember, this is our universal set, so we'll put 9 somewhere. So B says find X union Y complement. So this is question A solved. So X union Y, it's going to be a complement. It's going to be, for us to find our X union Y, it's going to be, that would be, we'll have 1, okay? Then we'll have 2, we'll have 3, we'll have 4, we'll have 5, we'll have 6, we'll have 7, and we'll have 8. So X union Y complement, it's going to give us the elements not found here but can be found in the universal set. And from our Venn diagram, we can also see that it's 9. So that is the solution to this question. Okay, so let's go to the next question on Venn diagram. Okay, it says draw a Venn diagram to represent the relationship between the sets. Okay, so we have a 3 variable set. We have our X to be 1, 2, 5, 6, 7, and 9. Okay, we have our Y to be 1, 3, 4, 5, 6, and 8. And we have our Z to be 3, 5, 6, 7, 8, and 10. Now to draw this Venn diagram, the first thing we need to find is, okay, we have to find X intersection Y. We have to find Y intersection Z. We have to find X intersection Z. And we have to find X intersection Y intersection Z. Okay, so X intersection Y is going to be, this is 1, this is 2, this is 3, and this is 4. So for 1, x intersection y is going to be, what are the items common to both x and y? So we have 1 it's common. What other number is common? 2 no, 4 no, 3 no, 5 is also common. We have 6. Okay, then for y intersection z, we're going to have 3, it's common. 5, it's common. And we also have 6 common. And we have 8 common. Okay, so we have 8. Then third one, we have our x intersection z. So our x intersection z, we have 5 to be the first common number, because here we can find 1 and 2, but there's no 1 and 2 here. So we have 5, we have 6, and we have 7. 5, 6, and 7. Okay, so the last one, that's x intersection y intersection z, it's going to be, now what is common in the 3? So we have 2 is not common, 1 is not common, 3 is not common, 4 no. Yet we have 5, it's common, we have 6 common. So we have 5 and we have 6. Okay, so 5 and 6 is common. So now we can now draw our diagram. So you have to make your diagram large because it has to take the 3 circles. So this is our first circle, this is our second circle, and this is our third circle. So I'll call this my x, I'll call this my y, and I'll call this my z. Okay, so now x intersection y intersection z, we had 5 and 6. Okay, so that's the first thing. Then the next one is x intersection y. Now notice in x intersection y, we've already written 5 and 6, so we'll just add 1. Okay. Okay, then in y intersection z, 5 and 6 is already here, so we'll add 3 and 8. So that's y intersection z, we'll put 3 and we'll put 8. And on x intersection z, since we've added 5 and 6, we'll just add 7. Okay, so now with this, what are the remaining elements in x? So we have 1 is already there, 2, we have 5, we already have 6, we have 7, then we have 9 here. And on y, we're going to have, we already have 1, we have 3, we don't have 4, so I'll write 4. We have 5 already in y, we have 6, and we have 8. So I think that makes 1, 2, 3, 4, 5, 6, and that is equivalent to y. And for our z, we already have 3, we have 5, we have 6, we have 7, we have 8, then we have 10 here. So this is our Venn diagram. If you check, all the elements have been captured. So this is exactly how to represent your Venn diagram. Stay tuned with us. We're going to be solving several questions on Venn diagrams. Hello, welcome back to the set theory class. If you've been following us, you will notice we've solved, we've explained the set theory. We discussed properties of a set. We discussed the complement, we talked about the complement, the intersection, and the union. And we also solved a couple of questions. And we've also treated the Venn diagram, the 2 and the 3 circles. So if you actually missed any of these, you can go back to the previous videos. You're going to see it down on the link where to go and get it. But now we are going to be solving approximately 10 questions on set. So if you stay with us to the end, you're going to learn more questions on set. Now question 1 says 24 people go on holidays. If 15 go swimming, 12 go fishing, and 6 do neither. How many go swimming and fishing? Draw a Venn diagram and fill in the number of people in all 4 regions. Okay, so I want to represent my information on a Venn diagram. Okay, So first of all, let's put out our parameter. So it said total, so the universal set is going to be 24. So it says swimming, I'll connote swimming with S, that's 15. And 12 go fishing, fishing is going to be 12. And 6 do none. So 6 is, I will say 6 do none. None is 6, either way. And how many go fishing and swimming? So that's swimming and fishing. That's swimming intersection fishing. We don't know that yet. So let's draw a Venn diagram to get this. Okay, so I will draw my rectangle. So this is my first circle, and this is my second circle. Now this is going to be my swimming. Now this is going to be my fishing. Now remember, we said where you have X intersection F, so we're going to call this X. So these are the number of people that go for both swimming and fishing. Now I want us to establish a particular fact. You know, the question says, let's represent 6 goes for none. So we need to represent that. So this is for 6, they go for none. So they are neither in fishing nor in swimming. Okay, now, some people are going to make the mistake of writing 15 here. So that's wrong, because among the 15 people that go swimming, some of them are in this X that go for fishing. So some of them are still, the swimming is made up of people who go for both swimming and fishing, swimming only and swimming and fishing. So that means instead of writing 15 here, I'll put 15 minus X, where 15 minus X is actually the number of people that do swimming only. So fishing will now be, this will be 12 minus X. So to get the total number of people who actually do this, that will help us find our X. So this will now be, total will be swimming only plus fishing only plus swimming and fishing plus none. So that will give us the total. And remember, our total, our U, it's 24. That's the universal set. So this is going to be 24 is equal to, swimming only is now 15 minus X plus fishing only, it's going to be 12 minus X plus swimming and fishing will be X, then plus 6. So when we simplify this, we are going to get our X. So this is going to be 24 is equal to, so we'll have 15 plus 12, and that will give us 27. 27 plus 6 is going to be 33. So this will be 33. Now we have a minus X plus X. So the minus X plus X is 0. So we have 33 minus X. So this will be, this is going to be, X coming over will be, X will be equal to 33 minus 24 when you collect your like terms. Therefore, our X is going to be 9. Okay, so from here, we can ascertain that the number of people who go for both swimming and fishing, it's 9. So now the question says, draw a Venn diagram to fill in the number of people in all 4 regions. So my real Venn diagram, it's now going to be, when I take out my X and represent it fully, it's going to be, so I'll draw my circle back again. So this is going to be 9. 15 minus 9 is now going to be 6. 12 minus 9 will now be 3. These are the actual number of people. So this will be 6. Now let's test this. For you to know that you got the actual answer, sum it up. That's 6 plus 9. That will give you 15. 15 plus 3 is going to give us 18. 18 plus 6 gives us our universal set, which is 24. So this shows you that the answer is correct. Okay, so the next one says, how many go fishing and swimming? So to get the number of people who go for fishing and swimming will be our X, which we have already found. So fishing intersection swimming, it's X, which is now 9 people. So I think everything in this question is solved. So if you treat this question this way, then you will get it right. Okay? So we will be going over to the next question. 3. Now, question 3 says, if P is equal to prime factors of 210 and Q is equal to prime number less than 10, find P intersection Q. Now, notice this is a multi-choice question, so our answer lies in between A, B, C, and D. Okay? So, now, prime factors of 210. So, for us to find the prime factors, we need to find that. So, we're going to divide 210 by its prime factors. 210 here, we're going to have 105. 3 can now go, 2 can go any longer. So 3 into 105 is going to give us 35. 5 can now go. 5 into 35 will give us 7. 7 can now divide. This is 1. So 210 is equal to 2 times 3 times 5 times 7. So that means our P will be prime factors of 210, which are 2, 3, 5, and 7. Okay, while our Q is going to be prime numbers less than 10. So we have 2 is a prime number, 3 is a prime number less than 10, 5 is a prime number less than 10, and 7. Wow, so our P and Q are the same. So it says P intersection Q. Remember when we talked about intersection, we said things that are common to both P and common to Q. So since all the elements are repeating themselves, our final answer is going to be 2, 3, 5, and 7. So this is the final answer. So our correct answer here is D. So D, it's our correct answer. Now the next question says, in a certain town, there are 82 pet owners who had either a cat, dog, or fish, or none. 41 had cats, 44 had dogs, and 35 had fish. 16 owned cat and dog, 17 owned cat and fish, while 14 owned dogs and fish. 3 people had neither of the pets. Find the number of pet owners who owned A, all 3 pets, B, only 1 pet, C, 2 pets only. Okay, now to solve this question, we need to represent all these parameters first of all. So the first thing we'll do is our U, it's our universal set is 82. Okay, so I'll represent cat. Cat is going to be C, which is 41. Okay, then dog is 44. Fish is 35. Okay, so we now have cat and dog is 16. Okay, so I think I need to shift my pen a bit. So cat and dog, it's going to be 16. Then we have cat and fish. Cat and fish is going to be 17. And the next one is dog and fish. It's going to be 14. So the next one is going to be dog, cat and dog and fish, which is our X. It wasn't given. So it says none, it's 3. So that's neither of them. Okay, so we are going to draw our Venn diagram. So, okay, before we draw our Venn diagram, there is something we need to get. Now, remember, in these 41 people who owns cats, these are not the only people that owns cats. Some of those people here actually own dog also, and some of them also own fishes. So we need to get the number that actually owns cat. So I will draw my diagram. This is my diagram for my 3 circles. So this is my first circle, this is my second circle, and this will be my 3rd circle. So remember, this is my X. People who own the 3. So this will be my cat, this will be my dog, and this will be the fish. Okay, so the people that owns cat and dog, we said cat and dog is 16. So, but remember, inside that 16, there are some of them that also own fish. So cat and dog will be, this is going to be 16 minus X. Okay, so for cat and fish, this is going to be 17 minus X. While for dog and fish, we're going to have 14 minus X. So now, to get our cat only is going to be 41. 41 minus. Okay, then you sum up all the elements in the cat. That's 16 minus x plus 17 minus x plus x. Okay, so why are we doing this? This is because some set of people here, the 16 minus x, we have some people owning dog and cat. So we need to take out the people owning the dog. So we'll get our cat only. So when you do that, you will not get this will be 41 minus, okay, so 16 plus 17 is going to give us 33. So we'll have our 33. We'll have our minus x plus x goes. So we'll have 33 minus x. So this is going to give us 41 minus 33. It's going to give us 8. So this will be 8. Then minus times minus will be plus x. So that's for cat only. Then for dog only, we're going to get 44 minus. Now for dog we have 16 minus x plus 14 minus x. Okay, so our minus x plus x becomes 0. So this will be 44 minus 16 plus 14 is going to give us 30. So this will be 30 minus x. When you open your bracket, you're going to get dog only to be 44 minus 30. That will give us 14. Then minus times minus will be plus x. So then to get for fish only, we're going to have 35 minus, this will now be 17 minus x. We sum up all the elements in the fish plus x plus 14 minus x. Now this is going to be 35 minus x plus x will give us 0. So we have 17 plus 14 and that will give us 31 minus x. Okay, so this will be when you open the bracket, you are going to get 35 minus 31 will give us 4 and we'll have plus x. Okay, so now we've gotten this. We've now known the individual elements. So we know now that in cat alone, we have 8 plus x. And we have our dog alone, we have 14 plus x. And for fish, we have 4 plus x. Remember, 3 owns none, so this is this. So when we sum up everything inside the rectangle, we are going to get our u, which is 82. 82. So now, let's sum up everything in our boxes. So now we will start by saying, okay, from here, my total is going to be now cat only plus dog only plus fish only plus cat and dog plus we have dog and fish plus cat and fish plus cat and dog and fish plus none will give us our total. Now remember, our total is what? That's 82 will be cat only is 8 plus x, dog only is 14 plus x, fish only, this is fish only will be 4 plus x, cat and dog will be 16 minus x, dog and fish, it's 14 minus x plus cat and fish will be 17 minus x. Cat and dog and fish, it's now x. Then I think plus none. Remember our none neither, it's 3. Okay, so let's add up everything. We need to collect like terms. 82 is equal to, okay. At this point, we need to sum up all the numbers. So we'll add 8 plus 14 plus 4 plus 16 plus 14 plus 17 plus 3. So adding up all the numbers, we are going to get 76. So we'll get 76. Okay. So here we have plus x is going to cancel. That's minus x. Plus x is going to cancel this minus x. So while we have another plus x to cancel this minus x, so we just have only one x left, and that's 82 plus x. Okay, so now at this point, we can collect like terms. So 82 minus 76 is equal to our x. And this will give us 6. Okay? So that means the people who owns 3 pets, that's cat and dog and fish, which is equal to x, is equal to 6. So this is our A solution. Now let's check what question B says. Now question B says only one pet. Only one pet. So for B, only one pet. So to get only one pet, that's dog only plus cat only plus fish only. Okay, so remember our dog only is 14 plus x, and our cat only it's 8 plus x, and our fish only it's 4 plus x. Okay, so now to get this, we will sum up the number. That's 14 plus 8 is going to give us 22 plus 4. This will give us 26 plus 3x. Now this is equivalent to 26 plus 3 times, remember our x, that's 6, which is 26 plus 18, and that will give us 44. So 44 people own 3 pets, own 1 pet. Okay, now question C. C says how many people own 2 pets only? Okay, now for our 2 pets only, we have cat and dog plus we have dog and fish plus we have cat and fish. Okay, so to get that, we need to look up. So I think cat and dog it's 16 minus x plus we have 14 minus x plus 17 minus x. Okay, so we are going to sum this up. Now this will be 16 plus 14 is going to give us 30. So and 30 plus 17 will give us 47. Then minus x minus x minus x will give us minus 3x. Now this is going to be 47 minus 3 times x is 6. So this is going to give us 47 minus 3 times 6 is going to give us 18. And 47 minus 18 is going to give us 29. So as easy as that, you can solve this question. Yes, I understand it's very complex, but this is one of the most serious questions you will always meet in Venn diagram. So you need to understand it. If you understand this particular question we just solved, every other Venn diagram question for you is going to be simple. In a class of 45 students, 28 offer chemistry, 25 offer biology. If each student offers at least one of the 2 subjects, calculate the probability that a student selected at random from the class offers chemistry only. Now, we can see a set question that has a relationship with probability. So, set and probability, they go side by side. Although you don't need to bother yourself whether you understand probability or not. Yet, I understand when you attempted your junior WAEC or your grade 9, your junior secondary, your junior high school, you were taught probability. But trust me, this probability is not a big one. So now let's connote our statement. Remember, it says U is 45. That's the total number of students. Chemistry, it's 28. Biology, it's 25. Chemistry, intersection, biology, if each student offer at least 1 subject. So we don't know that. Let's call that X. Now let's draw a Venn diagram to make it easier for us. So always learn to draw your Venn diagram. It's going to give you a descriptive measures of how to solve the question easily. Now remember, this is your X. Now this will be your chemistry and this will be your biology. So now chemistry is going to be will be 28 minus x to get only the people offering chemistry, while our biology is going to be 25 minus x. Now, I don't think there's anybody that does not offer, because the question says if each student offers at least one of the 2 subjects. So we don't have anybody not offering any of the 2 subjects. So now our U, remember our U is what? 45. So when we sum up everything in the elements, we're going to get our u. So this is going to be 28 minus x plus 25 minus x to give us our u, which is 45. So we are going to add 28 plus 25. So collecting our like terms, 28 plus 25 is going to give us 53. Now we have minus x plus x. That will give us 0 minus x is equal to 45. Now collecting our like terms, 53 minus 45 is equal to x. Therefore, our x is going to be 8 when you do that. Okay, so now we've been able to get the number of people who offer the two subjects, which is 8. Now the question says calculate the probability that a selected student at random from the class offers chemistry only. Okay, so let's get chemistry only. Now remember our chemistry only is 28 minus x, which is going to be 28 minus 8, and that will give us 20. So now we know the number of students who offer chemistry only as 20. The probability of chemistry only, remember your probability, you do, it will be probability of chemistry all over probability of the total, which is u. So this is going to be 20 over 45. What can divide through here? I think 5 can divide. So we will get 5 into 20 will be 4, and 5 into 45, it's going to give us 9. So our final answer is 5 over 9. So the correct answer here is C. So we are going to mark our C. Okay, so that will take us to the next question, which says, given that u is 1, 2, 3 up to 10, p is equal to x, where x is a prime, and q it's y, where y is odd. Now, from this question, you can deduce that p and q are subsets of u. Remember when we talked about subset, we said p and q are the children's set, are the child set of the universal set u. So the question says find p complement intersection q. Okay, so our u is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then our p is going to be all the prime numbers, so which are 2, 3, 5, and 7. Our q are the odd numbers, which are 1, 3, 5, 7, and 9. Okay, so p complement, remember when we talked about p complement, we said p complement are those numbers not found in p but are found in u. Now what numbers are not in p but are in u? 1 is not in p. Okay, 2 is there, so we will not use 2. 3 is in p, so we're not using 3. So 4 is the next number. We have 5, so we're not taking 5. So 6 comes next. We have 7, so we're not taking 7. So we have 8, 9, and 10. So p complement intersection q. What are those things that are common to p complement? Those numbers that you can find in p complement and can also find it in q. So 1 can be found in both. The next number we can both find is 9. Okay, so p complement intersection q is 1, 9. So our correct answer here is going to be A. So I'll mark A as the correct answer. And that will take us to the next question. Okay, the next question says if x is equal to 0, 2, 4, and 6, y is 1, 2, 3, 4, and z is 1, 3. These are all subsets of u. Find x intersection y prime union z. Okay, so now our y prime, remember those things that are not, first of all, I think we need to list our universal sets. So let's list it. So u is, remember it says 0 is less than or equal to x and is less than or equal to 6. So that is going to be 0, 1, 2, 3, 4, 5, and 6. Now be careful not to exclude 1 because it says it's using the sign less than or equal to, and also it's using the sign less than or equal to 6. So that is why 0 and 6 are inclusive. So our x is 0, 2, 4, and 6. Our y is 1, 2, 3, and 4. And our z is 1 and 3. Okay, so from here we can get So to perform X intersection Y complement intersection union Z, the first thing we need to do is let's get our Y complement. So our Y complement are those elements we will not see in Y but can be found in the universal set. So we have 0. So 1, 2, 3, 4 is out of it, and we have 5 and 6. Okay, so Y complement union Z. So remember our union is when you get union, you combine all the elements. So Y complement union Z is going to give us so I think I'll take the numbers in ascending order. That will be 0 comes first. I think there is 1 in Z, 3 is next, we have 5 next, then we have 6. Okay, so then finally to get our X intersection Y complement union Z, that means we are going to be comparing Y complement union Z with X, and we're going to find the numbers that are common. So in there we have 0, it's common, 1 is not common, 2 is not common, 3 is not common, and 0 it's common, 2 is not common, 1. I think the next number that is common it's 6. So that will be 6. So it's 0, 6. So this is our final answer, and we can see that option B is correct. Okay, so that will take us to the next question. Every staff in an office owns either a Mercedes and or a Toyota car. 20 owns Mercedes, 15 own Toyota, and 5 own both. How many staff are there in the office? Now, to get this question, draw your Venn diagram. It's your best shot, so it will help you understand the question better. So remember, some own both. That's 5 own both. Remember, this is going to be your Mercedes, and this is going to be your Toyota. So for Mercedes, 20 own Mercedes. So the real number of Mercedes will be 20 minus 5, while Toyota will be 15 minus 5. So to get the total number of people in the office is going to be 20 minus 5 plus 5 plus 15 minus 5. Now this is going to give us 20 minus 5 is 15 plus 5 plus 15 minus 5 is going to give us 10. Now this is going to be 15 plus 5, that's 20. 20 plus 10 is going to give us 30. So from here, I can deduce that the total number of people in the office is 30. So my final answer here is going to be B. So I'm going to tick my B. Okay, that will take me to the next question. Now this question says if n the numbers in P, element P is equal to 19, P union Q will give us 38, and P intersection Q, the number is actually 7. Find n of Q. Okay, I think there's an issue here, so I need to correct it. So the first thing you need to know here, it's your P, the number of elements in your P, it's 19. Your N, P union Q, it's 38. While the next thing you need to know, it's number of P intersection Q, it's 7. So to get our P only, you need to find P only first. Remember, P only is going to be 19 minus P intersection Q minus 7, which is going to give us 12. Okay, so how do we get our total when we sum up the whole total? If we were to draw a Venn diagram of this, let's draw a Venn diagram so it will guide us. So this is our P and this is our Q. So this is our P intersection Q. It's actually, this is 7. Now this is going to be 19 minus 7. P only is going to be 19 minus 7. This place is going to be we don't have Q, so Q is actually what we're looking for. So this is going to be we don't know this yet. So now, how do we get this? So to get the number of people in Q, what we need to do is we will say P only plus Q only plus P intersection Q is going to give us our total, which is the P union Q. That's 38. So our P only is going to give us 12 plus Q only, that's what we don't know, plus P intersection Q gave us 7. Now this will give us 38. Now what we need to do is add up the numbers. 12 plus 7 is going to give us this is 19 plus Q only will give us 38. Therefore our Q only is going to be 38 minus 19, and that will give us 38 minus 19 is going to give us that's 19. Okay, now we've gotten our Q only. To get the number of people in Q, remember, number of people in Q only included, this will be Q only plus those people in P intersection N of P intersection Q. Because let's assume some people who take attributes in element in item P also do Q. So to get the total number of people doing Q, it's going to be Q only, which is 19 plus 7, and that will give us 26. So our final answer is going to be 26. So we are going to mark our 26. Okay, so this is the last question for this series. I want to thank some of you who have stayed with us through this series before I solve this question. And if you really think this question, what we are doing makes sense, please hit the like button. Don't forget to share it with your friends, and also don't forget to hit the subscribe button. So now, given that P is equal to, it says P is equal to 1, 2, 3, 4, 5, and 6, because he used a sign less than or equal to, and is less than or equal to, then Q is going to be, it says 2, 3, 4, 5, 6, 7, 8, 9, and 10. And it says find X, where X is an integer, okay? Find N P intersection Q. Now, P intersection Q is going to be, now, remember our intersection, we're looking for numbers that are common, so we have 2, we have 3, we have 4, we have 5, and we have 6. Okay? So, now we have this. Okay, so this is our P intersection Q. Now, if you count the number of elements, then remember it says our X, it says X is an integer. So that means we are going to count the number of elements in P intersection Q. That is going to be 1, 2, 3, 4, 5. So the correct answer is 5. So as we can see, the answer is not in our options. So the options are all wrong. So the correct answer is 5. Okay, so thank you very much for staying through with us and the set topic. We want to appreciate you for staying through with us. Now, like I said, if you've not hit the subscribe button, hit the subscribe button. Please like the video. And if you think what we are doing, please drop a comment to appreciate us. We want to thank you for staying through with us. And we are asking you to hit the subscribe button so you can watch out for more enthusiastic videos that are coming up. Thank you and stay tuned.